correct our question. Maybe because you may not know like how to answer the question correctly. So we will answer the exam question. And after that, maybe we can have a look at the basic of the cryptography because I think the lesson of cryptography is very long and very large, but we only have like a 1 or 2 or 4 hour. So maybe today we can learn a little bit about the terminology, and then next week we will uh, learn more detail, and then maybe a little bit practice of how to use the cryptography. Okay. អញ្ចឹងថ្ងៃហ្នឹងយើងឆ្លើយសំណួរ exam យើងតិចទៅដើម្បីដឹងថាខុសកន្លែងណាត្រូវកន្លែងណាបន្តមកទៀតយើងរៀន cryptography តិចទៅព្រោះអី cryptography មេរៀនហ្នឹងតាមពិតទៅរៀនច្រើនណារៀនឡើងចង់30 40ម៉ោងក៏ប៉ុន្តែយើងយកមករៀនតែ4ម៉ោងយើងរៀនអាណាដែលសំខាន់អញ្ចឹងអាទិត្យហ្នឹងយើងមើលបានតិចតិចអញ្ចឹងទៅហើយអាទិត្យក្រោយយើងថែមទៀតទៅយើងអាចយល់ដឹងច្រើនអូខេ so related to the exam okay I think the question is very basic because mostly it is theory, and then you can find all the answer online. But the reason that people has a like full score or high score, or sometimes you lose a little bit score like 1 or 2 or 3 points because the answer is not like fully correctly. Okay, not like sometimes you choose the definition from the internet, but the definition not really like clear and catch the point, so it is just a different like that, but mostly most of you have a good result already. Okay, so firstly we talk about the definition of some words. So normally when we want to learn something we need to know some definition of the word. Okay, so we have a 5 definition, and then we have also 6 question. Okay, I think 6 question. So the first question is related to the when you see during the exam you have 7 question because the first question is the definition, the giving the definition of the 5 term. Some of you I think didn't read the question clearly because for example like here we have 5 definitions, some of you only answer 4 or 3, something like that. Maybe you miss something like that. And then during the question, some question I think that there is 2 question inside it. For example like question 3 we have what is the load balancing and also messaging protocol. Most of you answer correctly, but some of you only answer one, like answer the load balancing, but didn't answer the messaging protocol because these are the 2 different things. You see the word "and" here, so we have a load balancing and messaging protocol also. Okay, okay. So that is the mistake that some of you have did it. អញ្ចឹងសំណួរភាគច្រើនអ្នកខ្លះដូចថាឆ្លើយខ្វះឧទាហរណ៍ថានេះ definition ទាំងអស់មាន5អ្នកខ្លះភ្លេចមើលប្រហែលភ្លេចមើលឆ្លើយតែ4ទេឧទាហរណ៍ថា time of the day monotonic clock ស្មើតែ1ឆ្លើយតែ1អញ្ចឹងទៅឬមួយក៏សំណួរទី3នេះវាមាន2សំណួរនៅក្នុងហ្នឹងនេះទី1 load balancing ទី2 messaging protocol អ្នកខ្លះឆ្លើយតែ1ឆ្លើយតែ load balancing ឯងមូលហេតុហ្នឹងឯងដែលយើងឈប់បន្ទុកខ្លះយល់ទេបាត់បន្ទុកខ្លះដោយសារយើងឆ្លើយពាក់កណ្ដាលយើងអត់ឆ្លើយទាំងអស់អញ្ចឹងទៅ Okay, so like the first one, who can tell me what is the distributed system? តោះមានអ្នកគេអាចឆ្លើយបានអត់ distributed system គឺជាអីគេមានអ្នកគេ volunteer? Any volunteer? Because you have done already. So what is the distributed system? តោះវិជាមុនគេមកសវណ្ណវិជា What is the distributed system?
Yes. For my answer, distributed system is the collection or network of transistors that appear to is used as a single current system.
Again, please. ម្ដងទៀតមើល
Yes, sir.
ឆ្លើយម្ដងទៀតមើល
Distributed system is the collection or network of clusters that appear to its user as a single closed current system. Yes.
និយាយចេញមកដឹងអត់សូវចេះអង់គ្លេស Okay, so distributed system is a collection of something. Okay, you can say a collection of computer, a collection of machine, a collection of node, but as your friend said, a collection of cluster. Cluster is the same thing. Cluster is a bunch of computer. Okay, because cluster is made up of a server and a virtual machine or whatever, but normally it is a machine, it is a computer. So in short, you can say a collection of computer, a collection of machine. Okay, but what it do is that it appear to its user as a single, we call coherent system, which means that when you deal with those systems, you don't know that behind the scene there is a lot of system that of a lot of computer who is working. It appear to its user as only a single user. So that is a more basic definition of a distributed system. Okay, not one computer, but a bunch of computer working together. And then the keyword that catch the definition is about it appear to the user as a single system, as a single current system, which means that even though behind the scene there are a lot of server, a lot of computer who are talking to each other, but when user deal with those kind of system, user don't know that it is a lot of system, a lot of a computer behind. It appear that it only talking to one computer. So that is called a distributed system. Okay, but the last question I also asked, what is not a distributed system, so that we will deep into detail about behind the architecture. អញ្ចឹងគេសំណួរសួរថាអ្វីទៅជា distributed system ហ្នឹងចម្លើយដែលសាមញ្ញគឺវាគឺជាកុំព្យូទ័រមួយក្រុមបានន័យថាកុំព្យូទ័រច្រើនណាយើងអាចនិយាយថាច្រើនហើយវាអាចជួនកាលវាជាកុំព្យូទ័រជួនកាលវាជា server វាជាអីហ្នឹងទៅអញ្ចឹងឲ្យតែកុំព្យូទ័រច្រើនដែលវាធ្វើការរួមគ្នាក៏តែពេលដែលសម្រាប់ user ពាក្យដែលវាបានន័យថាវាត្រូវដែលគេអាសាប្រើហ្នឹងមានន័យថាសម្រាប់ user ពេលទៅធ្វើការជាមួយវាហ្នឹងទៅប្រៀបដូចជាវាកុំព្យូទ័រតែមួយគ្រឿងអញ្ចឹងបានន័យថាពេល user send request ទៅហើយពេលវាឆ្លើយមក user អត់ដឹងថានៅពីក្រោយហ្នឹងវាមានកុំព្យូទ័រច្រើនគ្រឿងឯតោះណាតែតាមពិតនៅពីក្រោយហ្នឹងវាមានរឿងច្រើនអាហ្នឹងឯងអា definition សាមញ្ញគឺប៉ុណ្្នឹងតោះណាកុំតែបើចង់ឲ្យចំមែនតែនទៀតអាហ្នឹងតោះតែយើងនិយាយថាវាមាន database ច្រើនវាមានស្អីវានៅ location ច្រើនឯទៀតអាហ្នឹងបានវា detail. So the simple definition is a collection of computer which work together and it appear to use its user as a single current system. But in detail, we can talk in detail like there's a lot of database behind. The computer is not located at the same geographic, something like that. So that is more detail. Okay. But for a simple definition, just like that is enough. Okay. But some of you may answer like differently. So you may not got full score, but also high score. Okay. So if you answer like this, you got 10 score, but if you answer a little bit more different, maybe 9 or 8, something like that. So it's just a little bit different like that. Okay, so socket. So what is socket? So if you answer only like one word or two word correctly, that is already you got full score. But if you like answer very long, but it's not related, maybe you don't got a good score. Okay. So socket is the short definition is an endpoint. So even if you said that socket is an endpoint, I also give you full score. Okay. But if you know in detail, like in the distributed system, I already told you about the component that the socket is made up of. So the socket is made up of IP address and a port number. So if you say that socket is a combination of IP address and port number, you also got full score. But if you didn't talk about endpoint or IP or port, you lose some score. Okay. So socket is an endpoint. It's a combination of IP and port. And sometimes you say that it is an instance of an endpoint with a TCP connection, something like that. Okay. But sometimes UDP also, because socket we have UDP, we have TCP. Some of you only said TCP, but UDP also has a socket. Okay. អញ្ចឹងគេសួរថាទី2គេសួរថាស្អីគេជា socket នេះ socket ហ្នឹងបើសិនជាយើងឆ្លើយយើងថាយើងនិយាយតែ endpoint ក៏ខ្ញុំឲ្យយើងត្រូវដែរតោះណាតាមពិត endpoint ហ្នឹងបើនិយាយសាមញ្ញ endpoint គឺជា computer មួយគ្រឿងឯងតែយើងនិយាយ endpoint ក៏ខ្ញុំឲ្យយើងត្រូវដែរក៏តែបើចង់ឲ្យវាត្រូវច្បាស់មែនតើទៀត socket គឺជា socket គឺផ្សំឡើងដោយ IP ហើយនិង port ពេលដែលយើងមាន IP address ចុច2ហើយនិង port ហ្នឹងអា2មួយគូហ្នឹងអាធាតុមួយគូហ្នឹងគេឲ្យយើងឈ្មោះថា socket ហើយអាមួយគូហ្នឹងគេឲ្យឈ្មោះថា endpoint ហើយតោះណាបានន័យថាយើងចង់ connect ទៅ endpoint មួយបានន័យថាចង់ connect ទៅ computer មួយគ្រឿងមានន័យថាម៉េចតើតើយើងស្គាល់ IP របស់វាហើយ port របស់វា IP សំដៅលើម៉ាស៊ីនមួយណាតើទៅ port សំដៅលើ software មួយណាអញ្ចឹងបានន័យថាយើងចង់តំណាក់តំណងទៅម៉ាស៊ីនមួយណាទៅ software មួយណាហើយអាហ្នឹងឯងគេហៅថា socket ចឹងយើងឆ្លើយថា socket ជា endpoint ឬមួយក៏ជាធាតុផ្សំនៃ IP និង port គឺខ្ញុំឲ្យយើង full point ហើយតែបើយើងអត់ឆ្លើយឲ្យចំអាពាក្យ2 3ហ្នឹងទេគឺអត់សូវបានបន្ទុកទេតោះណាហើយមួយទៀតអ្នកខ្លះគេថា socket គឺជា instance of a TCP communication នៃណាណីហ្នឹងតាមពិត UDP ក៏ socket ដែរព្រោះឯការ communication តាមបែប socket វាមាន UDP និង TCP មិនមែនតែ TCP តែមួយទេគ្រាន់តែ TCP យើងប្រើច្រើនតោះណាសម្រាប់ send text TCP used to send text something like that which is a reliable connection, but UDP is connectionless. So we used to send voice or video, whatever. And then the difference between time of the day and monotonic clock. So time of the day we refer to an epoch time, a language time, the time that since January 1st January 1970. So you need to mention that. So that is a time of the day. But some of you didn't know that. Maybe you didn't read, you didn't attend the class, or maybe you forgot, or maybe you whatever. You just said time of the day. It's just like today is January March 31st, 2022, something like that. So that is not correct. Okay. So time of the day refer to a time, a language time, and epoch time, the time that fixed when during January 1970. So that is time of the day that we are refer to in our distributed system. Okay, and monotonic clock is the time of the constant time that when the computer boot up. So when the computer boot up, there's also some clock who is running tick 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 tick, and it running continuously and constantly and no jump or whatever, just like what you said. So that is called a monotonic clock. And normally when we want to compute our algorithm, we use monotonic clock, but we don't use time of the day. Okay. អញ្ចឹងអា time of the day នេះបានន័យថាម៉ោងស្អីដែលយើងហៅថា time of the day ហ្នឹងគឺជាម៉ោងដែលអ្នកស្រាវជ្រាវខាងកុំព្យូទ័រទាំងអស់បានកំណត់យកតាំងពីឆ្នាំខែ1ថ្ងៃ1ឆ្នាំ1970ហើយវាទៅវាដើររហូតក៏តែអាម៉ោងហ្នឹងគឺវាដូចយើងនិយាយអញ្ចឹងវាមាន error វាមានអីហ្នឹងទៅតែតទៅពេលអា monotonic clock នេះគឺជាម៉ោងដែលកុំព្យូទ័រយើងពេលដែលបើកភ្លាមមកវាមានម៉ោងដែរម៉ោងហ្នឹងវារត់រហូតទឹកទឹកទឹកទឹកចឹងទៅហើយវាអត់ចេះឈប់ហើយវាថេររហូតហើយអាម៉ោងហ្នឹងដែលគេយកសម្រាប់យកមកកណនាតាក់ទងជាមួយនឹងរឿងតើ algorithm របស់យើងហ្នឹង run លបឿនប៉ុណ្ណាអញ្ចឹងគេប្រើ monotonic clock អូខេអញ្ចឹងច្បាស់កន្លែងហ្នឹងបើយើងអត់ឆ្លើយអញ្ចឹងទេគឺយើងអាចដាច់អស់បន្ទុកខ្លះហើយអូខេ so what is consensus algorithm? Consensus algorithm, normally algorithm is a code like the code that you are thinking you create, you write your own to create a bunch of software, so that is an algorithm. And consensus is an agreement. So when you say something related to an agreement, a collective of agreement, something like that, that is correct. Okay, but without the word agreement or whatever, you may not get full score. Okay. អញ្ចឹងអាពាក្យថា consensus algorithm ហ្នឹងធម្មតា algorithm វាគឺជា software វាជា code វាគឺជាក្បួនច្បាប់មួយហើយតែតទៅពេលអា consensus មានន័យថាម៉េចការឯកភាពគ្នាអញ្ចឹងដាច់ខាតត្រូវតែមានពាក្យ agreement នៅក្នុងហ្នឹងបើយើងអត់មាននិយាយរឿងស្អីដែលតាក់ទងមួយ agreement ទេបានន័យថាយើងឆ្លើយអត់ចំទេអូខេអញ្ចឹង consensus algorithm មានន័យថាគឺជា code ដែលតាក់ទងជាមួយនឹងរឿងការឯកភាពគ្នាហើយសួរថាឯកភាពហ្នឹងណាគេឯកភាពគឺកុំព្យូទ័រច្រើនមួយក្នុងន័យនេះយើងនិយាយរឿង distributed system តើណាបើថាកុំព្យូទ័រច្រើនវាឯកភាពគ្នាទៅរើរឿងអីមួយ output អីមួយហ្នឹងទៅអូខេ so any question related to the this five definition clear now ច្បាស់នៅអា5ពាក្យមិញព្រោះអីខែលោកពេលយើងរៀនហ្នឹងទៅយើងអត់ច្បាស់តែឥឡូវថ្ងៃហ្នឹងច្បាស់នៅព្រោះអីបើសិនជាយើងច្បាស់យើងឆ្លើយបាន100បន្ទុកគ្រប់គ្នាអីតោះណាអញ្ចឹងបានន័យថាវាមានអ្នកខ្លះអត់តន់ច្បាស់100%ទេច្បាស់ដែរតែមិនតន់ច្បាស់100%បើយើងច្បាស់100បន្ទុកគ្រប់គ្នាបាត់ហើយតែអ្នក100បន្ទុកហ្នឹងឃើញមានតែ6នាក់ហើយអ្នក9ជាងក៏ច្រើន8ជាងក៏ច្រើនដែរអញ្ចឹងបានន័យថាយើងឆ្លើយអត់តន់ចំអូខេ clear so if you answer correctly you may got full score but maybe you answer a little bit like not really fully correctly okay so let's see the first question what are the reasons that we want our system to be distributed so who can answer that Lý Hén why do we want our system to be distributed why we don't build our system just like a big software that full of feature and API inside only a single software why we want to build our system to be distributed Lý Hên thế nào bà đấy សង្ស័យបើកតែវីដេអូចោលអត់ស្ដាប់ទេយ៉ាងមិនអត់ចេះមើលបន្ទុកលីហេងមួយសិនបាទបានបន្ទុកតើសម្បត្តិ why do we want to build distributed system and not centralized system hello ហ្នឹងហើយឆ្លើយសំណួរនេះមើលនេះ
the reason that we want our system to be distributed because it provides scalability, improved performance, performance of the system and also provide availability and also reliability.
Okay, so normally if you only say a few keywords, I will give you full score. Like the first one is availability. Okay, why availability? Because centralized system can break down, and when it break down, we call the system go down or crash or downtime, something like that. So it means that it lost availability. So the difference between centralized system and decentralized or distributed system, the first one is availability. Okay, so if you mention about this keyword, you already got like 50% of the score already, because that is the main point. Okay, so the main point is availability. And sometimes you don't say availability, but you say fault tolerance, so that is also correct. It is also related to reliability and availability. So fault tolerant, which mean what does it mean? Fault tolerant, fault is a breakdown, okay, but tolerant it's handle the breakdown, so it means it availability. So when we talk about fault and fault tolerant, like Byzantine fault and Byzantine fault tolerant, you need to understand the keyword clearly. If you hear the word tolerant, which means it can handle, okay? But if you don't hear the word tolerant, which means it is the fault, okay? Like fault is a failure, but fault tolerant is a computer that can handle the fault, okay? So the first keyword is availability, and then you heard of the word reliability. So those two words are a little bit different, but mostly the same meaning, like reliable. So the system is reliable; it run all the time. So it means it's available all the time. That is the first keyword. The second keyword is about the scale. Okay, so if you talk that like the system can scale up, or it's scaling, or it's scale big, something like that, it's correct. Why? Because centralized system cannot scale. Why cannot scale? When you build everything in one computer, in one server, in one hardware, in one machine, those machine may reach a highest capacity. And when it reach those capacity, it cannot go further. It cannot scale. Okay. But distributed system allow you to scale your application. Like you for example, like you replicate your system into many place, into many database. And sometimes, for example, like your data doesn't need to be replicate the same thing. Here I give you an example. For example, like if you have one data here, it doesn't mean that you need to copy those data into another machine like this, like this, like this, and all your four machine has the same database. Distributed system doesn't always mean like that. Okay, sometimes you only cut, for example, like okay, only a few part. For example, like this is our centralized system. So in this part, I cut this part of the data, I put it here and put it here. Okay, and then there's also another part of the data. For example, like this part, I put it here and then put it here. Okay, and then you have another part of your data here. I put it here, I put it here, and maybe I put here. Okay, something like that. Okay, so and then normally we don't have three like this. We have a lot of replication. Okay, something like that. Okay, so for example, like this, and then these are the centralized system. So normally if your system is down, everything is down, data, service, or whatever. But when you replicate your data like this, you don't need to replicate everything in every computer, only a few data. For example, like if this data fail, you see that the red, the green, the blue is still in these two computer. Okay, so if this one fail, you still have a red here, green here, and blue here. Okay, for example, like if this one failed, you still have red here, blue here, and green here. So your data can replicate to a lot of database. So which means that even this data has full capacity, but when you have a lot of computer, you can scale it up. Okay. So the keyword is availability and scalability. About related to performance or security, it depends. So sometimes centralized system also secure, and sometimes centralized system is high performance than the distributed system, or yeah, distributed system. Okay, but the good keyword to justify why do we need to go distributed is the scalability and the availability. Okay. And then you can say it is secure, it is high performance. It's up to you, but it depends. It depends on how you build your system. Sometimes centralized system also secure, and then sometimes the centralized system is more high performance than the distributed system, because distributed system need to, if you use a Byzantine fault tolerant system, it take a lot of time for communication, and then the speed, the performance is slow. Okay, so it also depend on how you build your system. អញ្ចឹងច្បាស់ហើយសំណួរថាហេតុអីបានយើងចាំបាច់ទៅ distributed ទៅបង្កើត system distributed នេះបែប distributed system ហ្នឹងអូខេ ចឹងបើសិនជាយើងអត់ច្បាស់អាហ្នឹងទេយើងក៏អត់ដឹងថាយើងរៀនអាមេ distributed system ហ្នឹងដើម្បីអីដែរតោះណាអញ្ចឹងចម្លើយដែលពិតប្រាកដពីរដែលយើងទទួលយកបានទី1គឺ availability មានន័យថាវាអត់ចេះ down ទេ distributed system គឺអត់ចេះ down ហ្មងបើ system ណា down គេអត់ហៅ distributed system ទេតោះណា distributed system មានន័យថាម៉េចគឺជា system ដែលទោះបីជា computer មួយចំនួន down ឬមួយក៏និយាយកុហកក៏ដោយក៏ system ហ្នឹងនៅតែដំណើរការធម្មតាដែរអាហ្នឹងឯងដែលគេហៅថា distributed system ដែល definition របស់វានៅតាំងពីលើមកអញ្ចឹងអា distributed system ហ្នឹងគឺអីគេគឺគឺអីឆ្លើយចុះឆ្លើយឡើងចាំងកាំងគឺជា system ដែលវា available តោះនេះបានវាអត់ចេះ down តោះទៅពេលអាទី2តាក់ទងជាមួយនឹងរឿង scale បានថាយើងនិយាយឲ្យតែនិយាយរឿង scale គឺ centralize គឺមិនដែល scale បានទេតោះនេះមានតែ distributed system ដែល scale បានអញ្ចឹងឲ្យតែយើងឆ្លើយពីរចំណុចហ្នឹង availability and scalability ហ្នឹងគឺបានបន្ទុកពេញហើយតែបើសិនជាបាត់ចំណុចណាមួយអាហ្នឹងយើងអាចធ្លាក់បន្ទុកខ្លះអូខេ clear So the reason we want to go distributed is because the availability of the system, even the some of the computer go down or like fall or fake or malicious, the system still continuously functioning. That could also be the definition of the distributed system. Okay, like a bunch of computer who appear to user as a single core system. So that is a one definition. But you can also say that distributed system is a system that even some of the computer go down or even malicious, the system is still functioning. That is also a distributed system. And then it scale. Centralized system cannot scale. Okay. Okay. The next question. Cap theory. Okay. So normally in cap theory, you because here I said please explain in detail. Some of you didn't explain in detail. That's why you got like a 8 out of 10 score. But if you explain a little bit detail, I will give you full score. Okay, because here I say detail, and some of you like very short and summarize. So normally, what is a cap theorem? So first you need to know the definition of the three word CAP. Okay, so you need to provide some definition of it, and then you need to say that yeah, of course within the distributed system you cannot achieve 3 out of 3 property. You can only choose 2 out of 3. Okay. ចឹងបើសំណួរមួយទៀតគេសួរថាតើ cap theorem ជាអីគេគឺនិយាយទី1យើងត្រូវឲ្យនិយមន័យរបស់វាបានន័យថាអា C នេះជាអីអា A នេះជាអីអា P នេះជាអីនៅពេលដែលយើងឲ្យនិយមន័យអស់ហើយបានយើងនិយាយមួយទៀតគឺ cap theorem គឺគេចង់សម្ដៅថានៅក្នុង distributed system គឺយើងអាចរើសបានតែ2 property ក្នុងចំណោម3ទេគឺ distributed system មិនអាចមានរឿង3នឹងកើតឡើងក្នុងពេលតែមួយបានទេអូខេ So I will not explain again. You can go back to see the lesson, or maybe to see those some of your friends who got full score on that on it and check what did they answer. Okay, so CAP is stand for consistency, availability, and partitioning. Okay, partitioning tolerant. So you can check the lesson again. So that is the answer of the question 2. Yes, question 2. You have a 3 definition, and then you can choose only 2 out of 3 within the distributed system. The next question, we have 2 questions, load balancing and also messaging protocol. So you need to answer what is load balancing and what is messaging protocol. So now who can answer that? តោះសារីអ្វីទៅជា load balancing អ្វីទៅជា messaging protocol. So we may take a 1 hour for answer our question, and then the next hour we may learn a little bit cryptography. តោះជួយឆ្លើយគ្នាឆាប់ៗទៅដើម្បីចាប់យើងចូលមេរៀន Sari definition, what is load balancing and what is messaging protocol? តាមពិត Sari មុនហ្នឹងខ្ញុំហៅអត់ឆ្លើយម្ដងហ៎សង្ស័យ offline ទៅណាទៅណីបាត់ហ៎
មុនហ្នឹងអត់ហៅទេខ្ញុំ
មែនទេអត់ហៅទេចុះមុនហ្នឹងហៅណាគេដែលអត់ឆ្លើយហៅSari អាទិត្យក្រោយហៅបើកកាមេរ៉ាហ្មងណាគេអត់បើកកាមេរ៉ាដាក់ absent បារហើយ online ហើយតំណាក់បាត់ Okay វ៉ាន់នេះ load balancing and messaging protocol បើកវីដេអូ online ហើយទៅអង្គុយវាយ PUBG បាត់
Yeah, sure.
តើវ៉ាន់នេះ load balancing ជាអីគេដឹងហ៎ What is load balancing
Load balance. But load balancing is the process of distributing network traffic across the multiple servers.
again ម្ដងទៀតមក
Load balancing is the process of distributing network traffic across multiple servers.
Okay,
And
so yeah, you said like that is also correct, but it's also related to networking, network traffic. Okay, so normally load is a traffic. That's correct. Balancing, you balance the load. So that means you don't make one server overload. You distributed the load. So that is the role of the load balancing. Okay. អញ្ចឹងអា load balancing ហ្នឹងមានតាក់ទងមួយរឿងអា request រឿង client ដែលផ្ញើមកច្រើនហ្នឹងបានន័យថាបើសិនជាមួយលាន client ផ្ញើមកទៅតែមក computer ហ្នឹងច្បាស់ជា overload ហើយឬមួយក៏ go down ហើយអញ្ចឹងអាតួនាទីផា load balancing ហ្នឹងគឺវា distributed អា load ហ្នឹងបានន័យថា request ឬមួយក៏ traffic ហ្នឹងឲ្យវាទៅកាន់ computer ណាដែលត្នេ server ណាដែលត្នេ okay so I think I don't know if you can go to your friend answer or not យើងចូលមើលអាចម្លើយភពគ្នាយើងបានអត់ទេនៅក្នុង team for example like you can click on your friend and then you can see the answer yeah so client request access to system it redirect to the server that is available so normally it redirect to the server that is available sometimes your answer is not really fully correct but if the set I can send the real meaning I give you full score okay some of you because your English is not good but some of you like really answer very correctly and then let's look at another one okay so here you can see able to handle a lot of traffic it use a single process event driven model the use of I think some of you can copy from the internet this use load amount of memory enable proxy number of requests a proxy can balance the request between the application so so some of you I think maybe copied some definitions from the internet also but it is normal because I give you your privilege to look at the book and to search the internet, so it is okay. Question, what is the question? Okay, so load balancing can manage or prevent any single server from getting overload or accidentally breakdown. So you see that your friend is answering differently, but if the meaning is correct, I will give you the correct note. Okay. So normally you can see here it's about the overload of a single server. So here load balancing improve the service availability and prevent downtime, something like that. So even you say like that, I give you full score because the meaning is also correct. So normally the load balancing is to redirect the load, not to allow one server to get overload, something like that, and then it prevent downtime. So that is for the definition of the load balancing. But another one is a messaging protocol. So normally messaging protocol is related to communication. Okay. So if you mention communication, or for example, like defining a good data structure, data format for communication, so that is correct. Okay. Because a messaging protocol is the protocol that used for communication. And sometimes even like RAF or Paxos, we can also say that is also for communication because it has a communication path. For example, like load replication and voting, something like that. So the first communication is leader election. The other communication is load balancing. Not load balancing, log replication. Okay, so that is also the communication. Without those kind of protocol, the a lot of computer cannot talk to each other. So that kind of thing we say that it is a messaging protocol. Some of the software they combine the like all everything together. Like when you use some library, there is a load balancing inside, there's a security inside, there's also messaging protocol inside. So it is also depend on the software also. But this question is related to our first lesson. Like a simple distributed system normally have a load balancing in the front, and there's a lot of computer in the middle, and then those computers need to talk with each other by using some kind of communication protocols such as a messaging protocol. Okay. ចឹងអា messaging protocol ហ្នឹងតាក់ទងជាមួយនឹងរឿងបានន័យថាតើអា computer ទាំងអស់ហ្នឹងវានិយាយគ្នាដោយវិធីណាតើវានិយាយគ្នាតាមក្បួនច្បាប់អីគេដោយប្រើប្រាស់ software អីគេអាហ្នឹងយើងហៅថា messaging protocol អូខេអញ្ចឹងឧទាហរណ៍ថា for example like 0MQ it provide those kind of messaging protocol, and democracy JS it is a JavaScript written by one people. It's also a messaging protocol. It's allow computer to talk to each other. It's allow computer to choose a leader, something like that. Okay. So those are the messaging protocol. ចឹងឲ្យតែយើងនិយាយរឿង messaging protocol គឺយើងនិយាយរឿង communication. Okay. Okay, next question. How to solve the problem of NTP client and server which has different time? I think some of you maybe search the solution from the internet, like you need to open this software, click on this, click on that, something like that. So I didn't mean that kind of a configuration. Okay, so normally I refer to what we have learned during the class. During the class, when the clock has different, it has a different like error level. So if the error is very little, what should you do? If the error is a little bit medium, what should you do? If the error rate is very high, what should you do? So that is the real answer of the question 4. Okay, not like open your software to this page, to this menu, and click on this, click on that, and that your server will have the same time with the client. Not like that. Okay, that is a real configuration, but it is not refer to the question that we talked during the class. ចឹងតកតងមួយសំណួរទី4នេះអ្នកខ្លះគឺ check មើលអ៊ីនធឺណិតទៅបើកមើលអ៊ីនធឺណិតហើយទៅរកមើលថាតើដើម្បី configure អាហ្នឹងត្រូវធ្វើម៉េចបើកមនុយនេះចុច software នេះអីនេះអាហ្នឹងគឺយើងអត់ចង់សំដៅលើអាហ្នឹងទេតោះណាយើងចង់ព្រួយក្នុងមេរៀនក៏យើងអត់មាននិយាយរឿងទៅបើក software ចុចអីណានេះដែរមិនដឹងយើងបានរៀនមេរៀនអត់ទេអ្នកដែលយកអ្នកដែលឆ្លើយអាសំណួរអស់ហ្នឹងហើយមានមនុស្សច្រើនអ្នកឆ្លើយដូចគ្នាចឹងប្រហែលជា copy គ្នាបានឆ្លើយដូចគ្នាអូខេចឹងអ្វីដែលយើងចង់និយាយនោះគឺចង់និយាយថានៅពេលដែលម៉ោងនោះវាខុសគ្នាតើយើងដោះស្រាយវាដោយវិធីណាតោះណាព្រោះអីនៅក្នុងមេរៀនយើងនិយាយថា server ឲ្យ client ហ្នឹងវាមានម៉ោងខុសគ្នាហើយរួចទៅយើងដោះស្រាយវាដោយវិធីណា so the answer rely on the three different type of error rate here. Okay, so if the error rate is less than 125 millisecond, you just adjust the speed of the time, the clock. If the error rate is between 125 and 1000, you need to like reset your client side. Okay, but if the error rate is bigger than 1000 second, it's human who involved in the operation. Okay, so this in this case, the answer is like this. Okay, you need to answer like 3 different solution, like less than 125, between 125 millisecond to 1000 millisecond, and then bigger than 1000 second. And normally in our lesson, the error rate is referred to the data, the word data incorrect, like this one, like this. Okay, like this. But when you answer here, some of you don't use data, you use 0. Okay, and I think some of you may copy from other people. That's why even you don't answer correctly. So for example, like here you use Q and you use 0, but it's okay. I give you correct because your 0 is between these two nodes. But normally you don't need to, you cannot put 0 here. You need to choose some alphabet, for example, like Q or E or whatever. Okay, but some of you didn't do that. Like some of you I think I may give see maybe some of you has. Let's see question, and then let's move to the question NTP different time. Okay, so let's see. Some of you may answer like this. So some of you choose the word A, and then some of you written like this is okay. But there are people who, yeah, written like this. So see, you see like this. So what did you see here? If the different time is between 0 to 125 to 1000, the clock will be like this. So this is not a correct answer, okay? Normally, the second one is bigger than 125 and less than 1000. But your answer here is between 0 to 1 to 25 to 1000, so that is not the correct answer, okay? And then you can see the same answer with different people. That's why I said that people are copy with each other. You can see here another one, same thing, between 0 to 1 to 25 to 1000, okay? And then there's more, there's not only two. You can see here between 0 to 125 to 1000. I want to ask the question: how can 3 or 4 or 5 people answer the same thing, and then like the same phrase, exactly the same phrase, if they don't copy each other? Okay, ត្រូវអត់ខ្ញុំនិយាយត្រូវអត់បានន័យថាយើងប្រឡងរៀងខ្លួនអីរៀងខ្លួនកុំតែឆ្លើយចម្លើយខុសហើយអាខុសហ្នឹងគឺខុសដូចគ្នាបេះបិទទៀតឥឡូវសួរថាអាហ្នឹងមិន copy ទេតោះណា that is why I say there's a lot of copycat here. Okay, if I want to I don't want to reduce your score, okay? But if I want, I can, because you copy from each other, and then you can see why people answer the same thing if you don't copy each other. And then maybe another one is related to socket. Okay, I will give you one more answer, because when you copy every I know it. For example, the definition of the word socket. Okay, let's see. Let's see. How do I know that you copy from one another? Okay, so here you can see that the definition of the socket is an endpoint, but your endpoint is written incorrectly. So endpoint here, there is no O, okay? And then, for example, like one student may type incorrectly, maybe you type very quick or whatever, but why there are several people who are answering the same thing with the same mistake and forget about the O, something like that. Let's see. Socket. Okay, here. Okay. So why there's another student who also written endpoint but forget O also. Okay. How can it coincident like this? But it is not only two. There's also another student who are doing the same thing. Okay. So why a lot of students who are in their home with different computer, different keyboard, type the same thing? So which means you don't even type it, you just copy and pass it. Okay. I think there's a more student who are doing that. Okay. So is that a copy or not? អ្នកសួរទាំងអស់គ្នាមើលបានន័យថាឆ្លើយដូចគ្នាហើយបាទអក្សរហ្នឹង error ដូចគ្នាទៀតអញ្ចឹងមានន័យថាមានម្នាក់អ្នកសរសេរម្នាក់ផ្សេងទៀតអត់សរសេរមក copy paste បណ្ដោយ copy ឲ្យ paste យកហ្មងតោះនេះសំបីតាអក្សរ error ក៏ error មកដូចគ្នាដែរហើយក៏មកពីអាអ៊ីនធឺណិតហ្នឹងពេលតែទៅមើលអ៊ីនធឺណិតដូចគ្នាតែអាកន្លែងអ៊ីនធឺណិតហ្នឹងវាសរសេរ error ដល់ពេលយើង copy មក error ទាំងអស់គ្នាមកសើជួយឆ្លើយទីមើលអាហ្នឹងគេហៅ copy អត់ទេញ៉ាំវិជាអាហ្នឹងគេហៅ copy គ្នាអត់ទេ
បាទឆា
ហ្នឹងឲ្យច្បាស់ហ៎ error ដូចគ្នាអីដូចគ្នាហ្នឹងសំតែដកបន្ទុកម្នាក់20បន្ទុកចោល Okay, so next question. What is the different kind of the distributed system here? Okay, so this question I will explain you again because it is important. Some of you, most of you is answering correctly, but maybe we can answer again and then so that we are clear together. Okay. Byzantine fault tolerance system. A system using some kind of consensus algorithm, for example, like Paxos or RAF. Okay. because of Paxos, RAF is the same thing. RAF is the descendant of Paxos. And then the other one is it's not it's just a distributed database. Distributed, or maybe sometimes a replicated database. So what are the difference between them? Okay. ចឹងខ្ញុំចង់ឆ្លើយសំណួរមួយនេះឲ្យច្បាស់ម្ដងទៀតព្រោះអាហ្នឹងក៏វាសំខាន់ដែរគ្នាយើងឆ្លើយត្រូវខ្លះហើយ So what is a Byzantine fault tolerance system? Okay, so normally you can see here BFT refer to Byzantine. So Byzantine is just the name of the city. It doesn't matter. Fault, Byzantine fault. So as I said, remember when you hear the word fault and fault tolerant, okay? Because fault and fault tolerant is different thing. Tolerant, okay? So if you see Byzantine fault, what does it mean? Byzantine fault. Byzantine fault, it means you have a lot of member and some of the member can be malicious. Malicious doesn't mean it fall. Malicious can also be giving the wrong information. Okay. So in the case of some computer, the member of computer, the member of the cluster providing fake information, we call those type of fault Byzantine fault. Okay. And when we refer to Byzantine fault tolerant, which means your computer can handle those type of problem. Your computer can handle even some of the computer malicious or provide false or fake information. Your system is still work fine, no problem. So that is called a BFT system. Understand? ចឹងពេលដែលគេនិយាយរឿងអានេះអាតាក់តងមួយរឿង fall ហើយនៅ fall tolerant នេះយើងត្រូវចាំពាក្យពីរនោះឲ្យច្បាស់បើគេនិយាយរឿង fall អានោះមួយរឿងតែបើគេនិយាយរឿង fall tolerant អានឹងមួយរឿងទៀតតោះណាព្រោះ fall និយាយរឿងតាក់តងជាមួយនឹងរឿងមានបញ្ហាអា fall គឺបញ្ហាតែដល់ពេលបើគេនិយាយរឿង fall tolerant បានន័យថាអានឹងមិនមែនរឿងបញ្ហាគឺរឿងដោះស្រាយបញ្ហាវិញមានន័យថា tolerate ហ្នឹងមានន័យថាវាដោះស្រាយបញ្ហានឹងបានតោះណាចឹងបើគេនិយាយថា Byzantine fall បានន័យថាម៉េចគឺជា system ដែលវាមាន system ខ្លះគឺគេ compromise ហើយវា provide វាឲ្យព័ត៌មានคล้ายៗបានន័យថាអាចពិតខ្លះអាចคล้ายៗខ្លះអាហ្នឹងគេឲ្យឈ្មោះថា Byzantine fall ហើយឬមួយក៏ Byzantine fall problem អីចឹងទៅ Byzantine general problem អូខេតែបើយើងនិយាយថា BFT Byzantine fault tolerant មានន័យថា system ហ្នឹងគឺ handle អាហ្នឹងកើតតោះណាច្បាស់កន្លែងហ្នឹងអត់ So if we talk about Byzantine fault, the computer may be malicious and may provide fake information. But if it is a normal fault, it is not a Byzantine fault. If it's just a normal fault, so the computer could break down only. It didn't provide fake information. Okay, so you need to define those two. And then when we talk about this three system, we want to compare also how the computer can handle those kind of fault. So the first one, in order to handle the Byzantine fault or Byzantine general problem, we need the number of computer we call n. So the total number of computer need to be 3f plus 1, which means that if you have one computer fault, you need 4 computer. Okay, if you have 2 computer fault, you need 7 computer. If you have 3 computer fault, you need 10 computer. Otherwise, your system is not Byzantine fault tolerant. Okay, so n is the total number of computer or server that you need in order to handle this fault. Okay, so you can say 3f plus 1 or 3m plus 1, it's up to you. Okay, m or f fault or malicious is up to you. And then when we talk about the system with some kind of consensus algorithm, this is not a Byzantine fault tolerant system. It is just a system. We can say that it is a distributed because RAF is a good algorithm for distributed system. Even it has a leader, but when the leader die, it like a new leader. So it is also considered as a distributed system. Okay, but it is not Byzantine fault tolerant system. That's why we need only 2f plus 1 computer. So 2f plus 1 is a formula, but it's also the total computer. We can also say 2f plus 1 equal to n, or n is equal to 2f plus 1. N is the total number of the server that you need in order to handle some kind of fault. Okay, so it is a distributed system. It is some kind of fault tolerant system, but it cannot handle Byzantine fault because Byzantine fault needs 3f plus 1. Okay, minimum. Okay, so the distributed database, it is not a distributed system, but the only thing is your system, your database is very distributed, which means that your database is not go down easily. If one go down, we still have another one. Okay, that's why we only need a f plus 1. F plus 1 means if you have one, you need 2. Okay, if you have a 2, it's okay. You only need 3 because if one go down, you still have 2 more. Okay, so that is a very little requirement. But it the same thing. Your system cannot handle some fault or some Byzantine fault. Okay. So that is the difference. Sometimes people build a system is not really truly distributed. Only their database is distributed, but some kind of a server or whatever is still centralized. But when we look at their database, it's distributed. Why? Because when we build a system, there is a component of a client side. Okay, we have a server side. We also have a database side. Okay, so that distributed database, which means here the database is distributed, but sometimes during here it's not truly distributed. Okay, we are not talking about the client because client is only the one who requests to the server. Okay, so normally distributed database, which means their database is distributed, but the way that they design their server may not be distributed. Okay, so that's why we only need F+1. So for example, like they have 2 database. If one database go down, it's okay. They still want more. Okay. If you have 3 database, if 2 go down, even 2 go down, you still have one more. So it is okay. Okay. So your computer still access to that kind of database. But if you have only one server, your server go down, your system go down. You cannot handle this fault. Okay. But your database is okay, still available, but only your system is go down. Okay. ចឹងពេលដែលគេនិយាយរឿង3 system នេះមានន័យថាទី1គឺយើងចង់និយាយរឿង system ដែលវាគេហៅ fault tolerant Byzantine fault tolerant ហ្មងមានន័យថាទោះបីជា computer ណាដែលវានិយាយកុហកឬមួយក៏វាមិនមែន go down ហើយគេ compromise ហើយវា provide fake information ក៏ system ហ្នឹងដើរធម្មតាដែរតែដើម្បីឲ្យ system យើងคล้ายទៅជា Byzantine fault tolerant system បានតើតែចំនួនកុំព្យូទ័រសរុបរបស់យើងគឺស្មើនឹង 3f/1 មានន័យថា f ហ្នឹងគឺចំនួនកុំព្យូទ័រដែលអាចខូចដែលអាចនិយាយកុហកតោះណាបានន័យថាបើយើងចង់ទប់ទល់មួយកុំព្យូទ័រមួយនិយាយកុហកតោះតែយើងមានកុំព្យូទ័រ4គ្រឿងតែបើយើងចង់ទប់ទល់មួយកុំព្យូទ័រ2និយាយកុហកតោះតែយើងមាន7គ្រឿងតោះណាអាហ្នឹងគឺរូបមន្តគេចង់និយាយចឹង 3f/1 តែតទៅពេលអានេះមានន័យថាវាទប់ទល់រឿងកុំព្យូទ័រ go down មែនក៏តែបើសិនមានកុំព្យូទ័រមួយណានិយាយកុហកគឺវាទប់ទល់អត់កើតទេដោយសារចំនួនកុំព្យូទ័រយើងវាមានតិចតោះណាតែបើសិនជាឧទាហរណ៍ថាក្រោមនេះចំនួនកុំព្យូទ័រវាមានច្រើនអាហ្នឹងអូខេវាអាចទប់ទល់បានតោះណាអញ្ចឹងស៊ីសងលើកុំព្យូទ័រយើងមានប្រហែលគ្រឿងទេហើយតទៅពេលចុងក្រោយនេះមានន័យថាម៉េច server វាជួនកាលវាមិនមែន distributed ទេវា distributed តែ database ទេព្រោះដោយសារ database វាមានច្រើនអញ្ចឹងបើ database វាមាន3ងាប់2ក៏វានៅសល់1រស់ដែរតោះណាអូខេ clear ច្បាស់នៅតាក់ទងជាមួយនឹងsystem system ហ្នឹង system 3 system ហ្នឹង clear or not so remember when you look at one system see if the system is truly Byzantine fault tolerant system or if the system is not Byzantine fault tolerant, it's only fault tolerant. Okay, it is just a fault tolerant system, which is the number of the server can be a little bit go down, but it cannot handle when some of the computer provide fake information. So that is not Byzantine fault tolerant system. Okay, and sometimes the system is only distributed in their database, but the whole system is still centralized. Sometimes they say that, oh, my system is distributed because you see that my data is located in very different place, but that only distributed in the aspect of the storage. But for the request for the server or whatever, sometimes still centralized. That is a kind of the system that I don't say truly distributed in the last question. Okay. យល់ទេយល់សំណួរហ្នឹងអត់ច្បាស់នៅចឹងបានន័យថាមិនមែន system ទាំងអស់ឲ្យតែមានស្អីមួយ distributed គេហៅ distributed system ឯតតែយើងមើលទៅឃើញទាំងអស់ជា distributed បានគេហៅ distributed system អាខ្លះគ្រាន់តែ distributed នៅក្នុង storage អាខ្លះ distributed នៅក្នុង server តែ centralized storage អីចឹងទៅអាទាំងអស់ហ្នឹងយើងអត់ហៅវាថា distributed system ទេអូខេ Okay, so let's move to the last question. What is not a distributed system? So we have client. You can have a lot of client. Okay, 1, 2, 3 until 1 million client. It's okay. And then you have your server. Okay, your server could be 1, could be 2, could be 4, could be 5. Okay, and then you have your database, storage. Okay, normally database or storage. So normally when you build a system, it is like that. Okay, you have a lot of client requests. You have sometimes you have a load balancing here. Load balancing. Okay, in order for you to redirect you said redirect the request to the server, and then your server need to access to the database. Okay, so the last question is what is not considered as a distributed system? It appear to the user as a distributed system, but when we learn the technically, it is not really distributed. So what are those systems? តោះមានអ្នកគេអាចឆ្លើយសំណួរចុងក្រោយបានតើ system បែបណាដែលយើងមិនចាត់ទុកវាជា distributed system ចំតួកំហួយព្រោះយើងដឹងថា system ភាគច្រើនវាផ្សំឡើងដោយ client server ហើយនិង database ហ្នឹងទៅតើ system ប្រភេទណាដែលយើងអត់ចាត់ទុកវាជា distributed system
ចំពោះហេតុដែល system ដែលយើងអត់ចាត់ទុកជា distributed system ហ្នឹងមានដូចជាពេលដែលនៅក្នុង
និយាយតែមួយបានហើយទុកឲ្យគេនិយាយផងតើនិយាយតែមួយបានមកចំណុចបានហើយ
គឺក្នុងករណីដែលថា server ច្រើនប៉ុន្តែមាន database តែមួយ
Okay, done. So first one is correct. Okay, so everyone can talk. I think there's a lot of example, but if you answer one correct, I will give you full score. Okay. So normally you say that the distributed system, your computer has a lot of computer everywhere on the world in United States, in Singapore, but you only have one database. For example, which means that sometimes we call a shared database. So this computer, when a client connect to it, it save to this database. And when the client come here, connect to this server, it save to this database. And your database is very centralized. So that is not a truly distributed system. Why? Because you have a centralized storage. Okay, centralized storage. So if you have a centralized storage, it is not really distributed because when your database go down, even you have 1 million server, your system go down because it cannot access to the data, it cannot retrieve the data and provide back to the user. Okay, so that is not a distributed system, even though you have a lot of server. Okay, អញ្ចឹងចំណុចទី1ដែលយើងមិនចាត់ទុកថា system នឹងជា distributed បានន័យថា distributed ចំតួដោយសារ database វាមានតែមួយឧទាហរណ៍ភាគច្រើនគឺគេអត់ចង់ធ្វើបង្កើត database ច្រើនទេបានន័យថាគេចង់ធ្វើវាតែមួយហើយអា server ទាំងអស់ហ្នឹងទោះបីជា access តែ server មួយណាក៏ដោយគឺវា access មក database តែមួយហ្នឹងឯងហើយអាហ្នឹងបើសិនជា data មួយហ្នឹង go down គឺវា go down ឯធម្មតាត្រូវចាំតែស្អីក៏ដោយឲ្យតែមួយគឺ centralize ហើយតោះណាគ្រាន់តែវាអាមួយគេហៅ centralize server តទៅពេលអានេះគឺ centralize database អូខេអាហ្នឹងគឺជាចំណុចទី1 So when you have only one database, even you have a lot of server, that is not a distributed database because your single point of failure is related to your storage. Okay. So that is correct. So the other one who can answer another one, Song Heng. Which system that we don't consider as a distributed system, truly distributed system? Song Heng nói Song Heng. System ប្រភេទណាដែលយើងមិនចាត់ទុកវាជា distributed system ចំតួ
យ៉ាងច្រើនឡូច្រើន
ហ្នឹងឲ្យលឺតាឆ្លើយមក
សំដៅទីច្រើនវិញ
តើ system បែបណាដែលយើងមិនចាត់ទុកវាជា distributed system សំណួរទី6យើងប្រឡងហើយតាហើយក៏អត់បានឆ្លើយទេតើ system បែបណាដែលយើងមិនចាត់ទុកវាជា distributed system
មាន3ច្រើន
តែមួយបានឆ្លើយតែមួយបាន
មានBST system
អូខេអាហ្នឹងខុសហើយតោះនេះបើសិនយើងឆ្លើយ3ហ្នឹងមកខុសហើយសុងហេងចង់ទៅមើលក្រាស់ប្រឡងសុងហេងហ្នឹងតើពេលស្រាប់ទៅមើលក្រាស់ប្រឡងលឺឆ្លើយបាន100បន្ទុកពេញតើឲ្យឆ្លើយម្ដងទៀតមិនមែនណា 3 BST មិន
សំណួរទី7ដែរ
ហ្នឹងហើយសំណួរទី7សំណួរទី7
ថាសំណួរទី6
ចានៅក្នុងនោះខ្ញុំដាក់សំណួរទី6ហ្នឹងនេះសំណួរទី6តើឆ្លើយ
ប្រភេទដែលអត់ចាត់ទុកមាន 3 client ច្រើន
Mean 3 client.
No. We have mean two server and one database.
2 server and 1 database. That is the first question here that some of you already answer. Your friend already answer it. You have a lot of server, not 2. Okay, your server could be 1 million server, but only 1 database. Okay, hay anh đang có copy តគ្នាដែរអាចចម្លើយមិញហ្នឹងបានន័យថាគេកុំព្យូទ័រដែលមាន server 2តែមាន database តែមួយតាមពិតយើងមិនមែនប្រកាសតែ2ទេតោះណា3ក្រោយ100ក្រោយ1លានក្រោយឲ្យតែមាន database តែមួយគឺវា centralize ហើយគឺ centralize លើ database ហ្នឹងឯងតោះណាមិនបាច់ចាំបាច់តែ2ឧទាហរណ៍ថាអូពួកម៉ាក់ខ្ញុំឆ្លើយ2ខ្ញុំឆ្លើយ2ដែរហើយខ្ញុំព្រមឆ្លើយ10ក្រោយទៅដូរតែលេខ10មកបានន័យថាយើងចេះបាត់ហើយតោះណាបើគេឆ្លើយ2យើងឆ្លើយ2ដែរមានយើង copy គេតោះណាOkay, so I think yeah, during the exam, a lot of you answering like if we have 2 server, okay, 2 server and 1 database, it is not a distributed system. It is correct, but you don't say sometimes 2 is just an example. Okay, you can only say 1 million server. Okay, even if you have 1 million server, but you only have 1 database. So that is the first answer here. Your centralized database, so that is not truly distributed because when your database go down, your whole system go down. Okay, អាហ្នឹងគឺគេឆ្លើយឲ្យមិញនេះអញ្ចឹងបានន័យថាមិនបាច់ចាំបាច់តែ2 server ទេតោះណាទោះបីជា server យើងមានមួយផែនដីនឹងក៏ដោយតែ database យើងមានតែមួយនៅ techno ហើយខ្ញុំទៅដុត database នឹងចោលតោះណាអញ្ចឹងបើទោះបីជាយើងមានមួយលាន server នៅលើពិភពលោកហ្នឹងក៏ server យើង go down ទាំងអស់ដែរព្រោះវា access មកកាន់ database តែមួយអូខេហើយ database ហ្នឹងគឺនៅក្នុងបន្ទប់ techno ហើយខ្ញុំទៅដុតបន្ទប់នឹងចោលយល់អត់គឺខ្ទេច system របស់យើងតើអ្នកផ្សេងទៀតណាគេអូដាម Can you give another example which system that is not distributed system?
គាត់ឆ្លើយឲ្យនឹងឆ្លើយតាក់ទងទៅនឹង client បើសិនជា client ច្រើន server តិចតែ database មួយក៏វា go down
ហ្នឹងហើយអានេះចម្លើយទី1ហ្នឹងទោះបី client តាមពិតយើងអត់ខ្វល់ទោះបី client រាប់លានអ្នកក៏ដោយ server រាប់លាន server ក៏ដោយតែ database តែមួយអាហ្នឹងគេឆ្លើយហើយមានអីផ្សេងពីហ្នឹងទៀត
ឧទាហរណ៍យើងមាន server ច្រើនតែ database តែមួយហើយ client តិចក៏វា system ក៏ដល់ដែរ
ហ្នឹងដូចគ្នាហ្នឹងត្រែល client តិច client ច្រើនយើងអត់ខ្វល់ហើយ server ច្រើនមិនយើងនិយាយហើយ database មានតែមួយគឺយើងនិយាយហើយដែរអញ្ចឹងមិញខ្ញុំនិយាយបើយើងឡើងវិញយើងនិយាយថាបើសិនជា client ច្រើន server ច្រើន database តែមួយអាហ្នឹងគឺនៅតែដដែលហ្នឹងបានន័យថា database មួយតោះណាបើសិនជា client តិច server ច្រើន database មួយអាហ្នឹងដដែលនៅតែ client មួយនៅតែ database មួយអញ្ចឹងបានន័យថាអាហ្នឹងគឺជាចម្លើយទី1នេះមានន័យថាយើងអត់ខ្វល់រឿងអាពីរនេះមិនបានទេតែសំខាន់ឲ្យតែ database តែមួយគឺវាមិនមែនជា distributed system ទេតោះណាហើយតាមពិត client គេអត់ទាំងខ្វល់ទោះបីជា client ហ្នឹង1នាក់ក៏ដោយ1លានអ្នកក៏ដោយយើងអត់ខ្វល់ព្រោះវាគ្រាន់តែជាមនុស្ស access មកឯង
ឧទាហរណ៍មនុស្សច្រើនប៉ុន្តែ database យើង2 3ក៏អត់អាច store តន្ន័យរបស់ user ដែលនៅពេលដែលគាត់ request ចឹងទៅវាមានខ្លះវាមាន error អីចឹងទៅក៏វា go down ដូចគ្នា
អូខេអាហ្នឹងយើងនិយាយរឿងតាក់ទងជាមួយនឹងរឿង capacity ផុសម៉ាស៊ីនយើងឯងបានន័យថាម៉ាស៊ីនយើងវាទប់ទល់អត់រួចជាមួយនឹង user អូខេ
ចា
អាហ្នឹងអាចត្រូវដែរក៏តែភាគច្រើនបើសិនជានេះគេមានលុយគេ increase អា capacity ហ្នឹងឯងតោះអាហ្នឹងតាមពិតអាហ្នឹងវារឿងសំណួរ technical តែវាអត់ចំជាសំណួរនេះណាតែវាសំណួរ technical okay so your friend is answer for example like you have a few database okay you have few database your database is very distributed it's correct but you have a lot of user for example like 1 billion or 2 billion user something like that 2 billion requests and then your database has only a few for example like 2 or 3 so your database cannot handle a lot of requests from the server okay so I think that is related to the scaling or the capacity of your or maybe the cost the money of your company but it is not technically related to the distributed system the system is already distributed only you don't have money to buy more database okay so if you have money you just buy more machine, like buy more machine from buy more cluster from Amazon or whatever, your system is working fine. Okay, so that is not the problem of the technology but only the problem of the money only. Okay, chẳngអ្វីដែលយើងនិយាយមិញហ្នឹងត្រូវហើយក៏តែវាមិនមែនជាលក្ខណៈគេហៅ technical ទេព្រោះអាហ្នឹងវាដោះស្រាយបានបើតែឲ្យតែយើងមានលុយយើងប្រិច database ហ្នឹងឲ្យតែច្រើនទៅអា request client មកទោះបីជាវាប្រហែលក៏វា handle បានដែរឲ្យតែយើងមានលុយទិញ server ច្រើនតោះណាហើយ system របស់យើងប្រភេទហ្នឹងគឺ distributed ទេបានន័យថា server ច្រើន client រាប់លានអ្នកហើយអា database យើងចេះប្រិចឲ្យបានច្រើនម៉ាស៊ីនអញ្ចឹងទៅអញ្ចឹង system យើងគឺនៅតែដើរធម្មតាអញ្ចឹងតោះណាអត់ដើរហ្នឹងដោយសារតែយើងខ្វះលុយទិញកុំព្យូទ័រអញ្ចឹងវាមិនមែនតាក់ទងមួយរឿង technology វាតាក់ទងមួយរឿងលុយវិញអូខេ
ចំណុចទី3តាក់ទងទៅនឹង client ច្រើនប៉ុន្តែ server តែមួយអញ្ចឹងវាដើរយឺត
អូខេអាហ្នឹង centralize ហ៎អូខេត្រូវហើយអាហ្នឹង so the first point is related to centralized database but the other one is related to centralized server. Okay, centralized server, which means that you have a lot of database. It is okay, you have a lot of database, but you only have one single server here. Okay, so normally we can say that your system is centralized. Your system has only one server. Okay, one server, one database. So if you have one server, even though your database has a lot of database, if your server go down, it still go down. Okay, I think there's two more point that could okay, so ឧត្តមបានហើយត្រូវហើយចឹងបានន័យថាទី1 database មានតែមួយទី2 server មានតែមួយបើទោះបីជាគេនិយាយថាអូនៅពីក្រោយខ្ញុំប្រើ distributed database ឧទាហរណ៍ដូច MongoDB ដូច CrowdDB អីចឹងតោះនេះបានថា database យើងគឺ replicate គឺ distributed តែតោះពេលតែមើល server មានតែមួយឯងតោះនេះតែមើល server នៅ cloud មានតែមួយឯងចឹងអា server នឹង go down ទោះបីអា distributed database ក៏ទប់មិនជាប់ដែរអូខេតោះសុភា do you have any other idea?
No, teacher.
Okay, ឥឡូវណាគេ volunteer any other idea? Because I think in the exam some of you are different answering correctly. There are still some idea that we don't consider as distributed system. Okay, so single database is not distributed system, single server is not distributed system, and then there are still two more to answer. But if you answer only one correct among the four, I give you already full score. តើមានអ្នកគេឆ្លើយបានអត់ system ប្រភេទណាដែលយើងមិនចាត់ទុកជា distributed system? Author, you have any idea? Any other answer?
No, I just say that it was part of systems that are in the same physical location. So, for example, solo game applications that store data on your computer, like Word, Notepad, or I don't know.
Yeah, so I think we have five points now. I also forget that part. Okay. Okay, so first one server. Okay, one server. So if you have one server, we can also call it a centralized system. So one server, when one server go down, it's not a distributed system. Okay, one database. If you have an server, but your database is only one, it's also not good. Okay, for example, another one, you have a lot of database, okay, and database. You have n server, okay, but for example, everything located in one place. Okay, so your system is distributed, but the problem is you have a very high risk because everything located at the same physical location. For example, like I have a big server here. I have one big server, and my server can put a lot of hard disk here. Okay, put a lot of hard disk. And then, for example, like this hard disk is my first database, this hard disk is my second database, something like that. Or maybe I have a big server and then I create a lot of virtual machine. Okay, so this called machine number 1, peer number 1. This called peer number 2, something like that. Okay, peer number 2. So everything located in. So this one is everything located in one big server. So that is refer to the first one also. When the server go down, your database, your server will go down. But sometimes you have a 2 server side by side, or maybe 3 servers side by side. But your system located at the same physical location. Okay, physical location. So when there's a high risk that when there's no electricity or firewall or some disaster happen, everything go down. Okay, so it is related to the geolocation. Okay, geography. So remember that your system is distributed. It's true, technically it's true, but it is high risk because it is located at a single location. Okay. Chẳngមួយទៀតមានន័យថាម៉េចបានន័យថាបើយើងនិយាយពីផ្នែក technology វាត្រូវហើយអូខេ database មានច្រើនត្រូវហើយ server មានច្រើនត្រូវហើយតទៅមើលអាទាំងអស់ហ្នឹងទុកក្នុងបន្ទប់តែមួយតោះណាបានន័យថាបើនិយាយពី technical វាត្រូវហើយបានថាវាចាត់ទុកជា distributed system ហើយតែគ្រាន់តែវា high risk ត្រង់ថាយើងទុកវានៅក្នុងកន្លែងតែមួយអញ្ចឹងបើសិនជាដាច់ភ្លើងឬមួយក៏ឆេះបន្ទប់ហ្នឹងឬមួយក៏អីគឺទៅទាំងអស់ហ្នឹងតោះណាអញ្ចឹងអាហ្នឹងបើយើងនិយាយពី technical វាអាចជា distributed system តែវាគ្រាន់តែ high risk. Okay, so the last two maybe I can answer. I think maybe the last two is the same thing. Maybe we call it a decentralized system. Okay, decentralized. So when you look at the system, we have a three type of system. We have a centralized, we have a decentralized, and then we have a distributed. Okay, so decentralized, what does decentralized mean? Decentralized means you have a several server, but each server maintain a bunch of their cluster. Okay, you have a lot of server and each server maintain a bunch of cluster, and then those server communicate with each other. Okay, but when one of your server go down, a whole cluster here also cannot access, but these two still working fine. Okay, so which means that your system is a little bit spread across the region, have a lot of database, but it still has a leader and follower relationship. Okay, leader and follower. So if you have a leader follower, if your leader go down, all your follower cannot work functioning. Okay, so this type of system is a decentralized system. So it is not really truly distributed, but still some of the region is work fine, but some of the region cannot work at all. Okay, but if we take only one system to discuss, for example, like we have 4 computer. Truly, your computer is a lot. You have a lot of database. It's correct, but your system is created in the form of leader follower architecture. Okay, leader and follower. And then you don't use a Paxos or rough consensus in order to choose the leader. This leader will be the leader all the time. Okay, so even though you have a lot of server, even though you have a lot of database, but when you have a leader follower relationship, and then when your leader is going down, your system is also go down. Okay, so that is 4 is the decentralized, but 5 is only one case. For example, like we have a lot of computer, but you only have one server, one leader, and a lot of follower. If your leader go down, you also go down. Okay, and maybe I can talk one more, number 6, related to some kind of service. For example, like you have a lot of server. Okay, you have a lot of database, but in order to access to the server, you have some kind of service. Okay, for example, load balancing service. And then you have only one load balancing service. So it could be a load balancing service. It could be a system that using Zookeeper, like you said, you used to see Zookeeper. So if those service, in order to reach our cluster, you need to go through a service. Okay, and those service is only one. Okay, one service, one single service. That is also not really distributed. Here is this aspect is distributed already. It's true. A lot of server, a lot of database. But in order to access to those server, you need to go through one service. And when those service go down, your system also go down. Unless your service is also distributed like 2 or 3 service. Okay. So if one go down, your client still go to another one. Okay. So remember that distributed system is hard, and to build it is also hard. And sometimes you only see only small aspect of distributed system, like distributed database, distributed server, but sometimes there's still some single thing. For example, like single server, single database, single service, single leader. So if you see something related to single, that means it is a single point of failure. Okay, and it is a weak point of the centralized system. Single point of failure.
Teacher, I have a question.
So
blockchain ជាប្រភេទ decentralized ឬក៏ជា distributed
ទៅតាម blockchain time blockchain. Okay, maybe so now you have 6. Maybe I can add more 7 because some of you already answer in the exam also. Okay, we can discuss now. I think maybe we don't need to go to the cryptography because we don't have time. Okay, we may discuss. You can answer. You can have a lot of question and then we can discuss. Okay, so now we have 6. Maybe we can talk about the 7 and then you can maybe you can copy it. Okay, because these are not the distributed system. So your friend is asking about the blockchain technology. Okay, is it decentralized, centralized, or distributed? Okay, and then we haven't studied it yet because it is in our second chapter. So when we talk about blockchain technology, so I will not talk in detail because we will learn next week or some other week. We have Bitcoin. Okay, we have Bitcoin. We have Ethereum. We have a Hyperledger because we are going to learn this 3 things, and then we have the other. Okay, okay. So Bitcoin is a peer-to-peer system. Okay, and then we call it truly a distributed system. Okay, and it uses a consensus called proof of work consensus. So I don't explain in detail, so we will learn in our lesson. Okay, so Ethereum is using a proof of stake. Okay, and then Hyperledger is using a RAF. So if we compare only these three blockchain. So remember, blockchain is just a general term, but we need to study like what kind of blockchain are you using. Okay, for example, like my system is using blockchain, it doesn't make any sense. Okay, but if you say my system using Bitcoin blockchain, using Ethereum blockchain, or using Hyper blockchain, then we can discuss. Okay, but if you say that my system is using blockchain, I don't know what kind of blockchain. Okay, chẳng bạn ấy thay bờ sinh cái khoản ảnh giấy tha ố system của nhóm per blockchain nó đang mà phía xa mà vậy bố em đang thà blockchain nó việc mà vậy thằng ấy từ thở xua cái bên tha task blockchain nó blockchain này per bitcoin rồi mới có per ethereum rồi mới có per hyperledger. Okay, for example, like our national bank using hyperledger, but hyperledger also have a lot of hyperledger. Okay, we have hyperledger fabric. And then the National Bank of Cambodia using Hyperledger called Iroha, okay, to build a blockchain banking system. Okay, so for example, like my banking is using blockchain. I don't know what blockchain, but your system is using Hyperledger Iroha blockchain. So that is the real blockchain that we would like to discuss. Okay. So if we talk about these 3 blockchain, which one is distributed, which one is centralized, which one is whatever. Okay, so Bitcoin is truly distributed. Some of you say that Bitcoin is not distributed. It is not true. Bitcoin is distributed. Okay, because it is using a proof of work consensus algorithm. And then if you see the proof of work consensus algorithm, you will know that this algorithm everyone can join it. And then every computer need to if we will learn if every computer need to compute something we call a hash number. So if you find the correct number, you can be the computer that make the decision. Okay, so which means that if you have a lot of computer, we don't know which one is the leader. Unless you find the true answer, you become a leader. So the way that you find the true answer is about the consensus algorithm called proof of work. Okay, so that is called sometimes we call peer-to-peer system. So peer-to-peer system is also a distributed system. Okay, but this Bitcoin, we call it, for example, like 2008 Bitcoin. Okay, so 2008 Bitcoin is a distributed system, but now it's 2000 what 2022. Okay, so from 2008 to 2022, people start to change something. Okay, they change the architecture, they change the database, they change the way they coding, they change the data structure, they change the consensus algorithm, they add something. So in that case, we need to discuss like which part is distributed and which part is centralized, because there are some still the whole system is distributed, but there's still some part that consider as centralized. Okay, so that if we want to discuss like that, but in general, Bitcoin is a distributed system. Okay, it is a peer-to-peer system. That's why Bitcoin is very slow. Just like I said, when the system is truly distributed, the performance is not good. Okay, So if you want to have one transaction happening, you need to wait like 6 hours. Okay, 6 hours or sometimes 1 hour or whatever. Okay, it's very long. And then Ethereum, because proof of work taking a lot of time, like speed is very slow. This Ethereum using another consensus called proof of stake, which means that here you have 1 million computer, but here you have 1 million computer, and you choose only a few to become the leader. For example, like 21, okay, and 1 million computer here. So all the 1 million computer is a follower, but you have another layer called a leader, and then you have, for example, like 21 leader, okay. So your leader is take turn to make decision. So that is called a proof of stake decision, and your leader is taking decision because you put money, because Ethereum is a cryptocurrency blockchain. So you put some money here, and then you become the leader, and then you can make decision. Okay. So when you look at this kind of system, it is not 100% distributed, but it is not also decentralized. It is in the between the decentralized and distributed. So if you have centralized here, you have a decentralized here, you have distributed here. So Ethereum is in between. Okay, so it's here. Okay, it between the decentralized and the distributed. Understand? And then if we talk about the Hyperledger, it uses rough consensus protocol. Okay, so rough, if you have a 4 computer, your 4 computer can talk to each other, okay, and then can select some to become a leader, something like that. And then you can see that RAP is not a Byzantine fault tolerant system. So that is one reason. The other reason is that it is using consensus algorithm. But Hyperledger is not using RAP. It also using another thing called orderer. Okay, there's another computer in the front, just like here. So if you have only one orderer, we can say it is a master computer or a server computer. So you have a lot of follower computer and one leader. So in this case, it's not distributed. But sometimes you have a 2 or 3 in the upper part, and then you have a lot of client server, follower server here. Okay, so in this case, your Hyperledger is considered it's similar to the Ethereum, because here you have 21, and then here you have 3 or 4. Okay, that make decision over a lot of computer here. Okay, so if we want to discuss about the blockchain technology, it depends on which technology that you are using. So some is truly distributed, some is a little bit we can say decentralized, or it between the decentralized and distributed. Okay, and still here there is an aspect of centralized and decentralized here. Okay, so it is not related to blockchain technology. It is related to the specific blockchain technology, like what kind of blockchain that you are using. Okay. អញ្ចឹងសរុបមកវិញបានន័យថាបើយើងចង់ discuss រឿង blockchain សួរថាតើ blockchain ហ្នឹងវាគឺជា distributed system អត់អាហ្នឹងគឺវាអាស្រ័យទៅលើថាតើយើងចង់និយាយរឿង blockchain មួយណាតោះណាអញ្ចឹងពាក្យថា blockchain វាគ្រាន់តែជាពាក្យ general ទេវាគ្រាន់តែជា term general ទេកុំតែសួរថាពេលដែលយើងយកវាមកប្រើឬខ្ញុំចង់បង្កើត system មួយដោយប្រើ blockchain មួយសួរថាយើងយក blockchain អីមកប្រើបើយើងយក Bitcoin អាហ្នឹង distributed បើយើងយក Ethereum វានៅចន្លោះ distributed ហើយនិង decentralized តោះណាបើយើងយក Hyperledger អាខ្លះ centralized ហ្មងដោយសារអីដោយសារវាមាន server តែមួយឯងអាហ្នឹងគឺ 100% centralized ហ្មងតោះណាតែតទៅពេលអាខ្លះទៀតគឺដោយសារតែវាមាន server នេះច្រើនគួរសមដែរ1 2 3 4 5ហ្នឹងទៅអញ្ចឹងអាហ្នឹងក៏វាស្តៀងទៅនឹង Ethereum ដែរអូខេអញ្ចឹងសរុបមកវិញពេលដែលគេនិយាយរឿងថាខ្ញុំ system ខ្ញុំប្រើ blockchain system ខ្ញុំគឺ distributed system ដោយសារ Bitcoin គឺ distributed តោះណាកុំតែតទៅទៅមើលមិនប្រើ Bitcoin ផងហ្នឹងប្រើផ្សេងផ្សេងហ្នឹងអញ្ចឹងអាហ្នឹងគឺអត់ចាត់ទុកជា distributed system ទេអាស្រ័យទៅលើថា system យើងមាន server ច្រើនអត់មាន database ច្រើនអត់តោះណាបើសិនជាក្នុងចំណោមអាទាំងអស់ហ្នឹងហើយមាន service ច្រើនអត់បើសិនជាក្នុងចំណោម3 aspect ហ្នឹងមានអាមួយណា centralized អាហ្នឹងគឺមិនមែន distributed ទេអូខេ did I answer your question មិនណាគេសួរមិញ
Yes thank teacher
សារីសួរអូខេហ្នឹងហើយឥឡូវសារីសួរឥឡូវទាំងអស់គ្នាយល់នៅបាទ clear so blockchain in 2008 there is only one blockchain which is Bitcoin and then Bitcoin we call it a peer-to-peer system so peer-to-peer system is a distributed system okay but remember now it's 2022 not 2008 which means even Bitcoin has a lot of evolution like modifying the structure the code or whatever and then there is a lot of like 1,000 1 million other blockchain coming up Ethereum like Hyperledger, Hashgraph, IOTA, Binance, or whatever, and then those they said they are blockchain, okay? But when you go to see the like what the behind the technology, it is not truly distributed, okay? តោះពួកម៉ាក់យើងបរាំងរត់ចោលមួយបាត់ហើយ offline មួយបាត់ហើយអូខេតោះមានសំណួរទៀតអត់ច្បាស់នៅតាក់ទងនឹងថា system មួយណាដែលវា distributed ឬមួយក៏អត់
ឆ្លើយនៅក្នុងចំណោម7ហ្នឹងបើសិនជាយើងឆ្លើយសំណួរមួយណាបន្ទុកពេញមែន
ហ្នឹងហើយឆ្លើយតែមួយបន្ទុកពេញ
ខ្ញុំ
អត់ឲ្យយើងឆ្លើយទាំងអស់ហើយ
ខ្ញុំឆ្លើយមួយcentralize ហ្នឹងប៉ុន្តែបានតែ6ហ្នឹងគ្រូ
អូអា centralize ហ្នឹងអត់តន់ចាំតួទេព្រោះ centralize វាមិនមែនជានេះទេតាមពិតបើសិនជាយើងឆ្លើយតាក់ទងមួយនឹងអាផ្សេងក្រៅពី centralize អាហ្នឹងបានពេញព្រោះ centralize វាមិនមែនជា centralize ហ្នឹងវា centralize system ហ្នឹងតែបើឆ្លើយអាផ្សេងទៀតនេះដូចជានេះអាផ្សេងទៀតអាហ្នឹងឲ្យពេញដូចជាស្អីគេតាមពិតបើសិនយើងមានឆ្លើយ decentralize អត់ centralize មួយ decentralize អត់ឆ្លើយ decentralize ណាឆ្លើយតែ centralize តែមួយទេ
ឆ្លើយតែ centralize តែមួយ
ហ្នឹងហើយឆ្លើយ centralize តែមួយវាអត់តន់ចាំតួព្រោះ centralize វា centralize system ហ្នឹងធម្មតា centralize system វាមិនមែន distributed system ស្រាប់អីហ្នឹងតើតើយើងនិយាយរឿងនេះអា database មួយឬមួយក៏ server មួយអីណាហ្នឹងបានវានេះអូខេបានវាច្បាស់ព្រោះយើងចង់និយាយថា system ហ្នឹងវា distributed system ហើយកុំតែវាមិនចាំតួជា distributed system ហីអូខេអាហ្នឹងសំណួរដែលយើងចង់សួរតើពេលយើងនិយាយ centralize អាហ្នឹងវារឿង centralize system ផ្សេងហី
អាហ្នឹងខ្ញុំនិយាយឧទាហរណ៍ពី client ពី server ពី database តែគ្រូ
និយាយថាមិនខ្លះឧត្តម
និយាយថា
មើលខ្ញុំទៅមើលតិចមើល
ហ្នឹងគ្រូ
ហើយ score យើង full score បានប៉ុន្មាន
បាន89
89ចាំបានអីទៀតលោក
តែ89
ហ្នឹងកំពូលឯងមិនបាច់ទៅមើលទៅ89ច្រើនគួរសមអីហ្នឹងឥឡូវយើងមើលយើងរៀនមុខវិជ្ជាណាដែលបាន89 89ហ្នឹងច្រើន score យ៉ាងវាមិនអីទេ
teacher សំណួរទី1ខ្ញុំភ្លេចឆ្លើយ consensus មួយឆ្លើយដក10ទូ
សំណួរទី1ភ្លេចឆ្លើយ consensus
បាទចា
តាមពិតដក10បន្ទុកហ្នឹងមិនមែនដោយសារយើងភ្លេចឆ្លើយមួយដោយសារយើងឆ្លើយផ្សេងទៀតក៏វាអត់ចំដែរអត់ចំតួត្រូវមិនមែនបានន័យថាអត់ឆ្លើយមួយអស់10បន្ទុកទេណាជួនកាលឧទាហរណ៍ថាសំណួរទី1វាមិន25បន្ទុកត្រូវទេ
បាទ
ហ្នឹងហើយអញ្ចឹងបានន័យថា definition បាន5បន្ទុកអញ្ចឹងបានន័យថាបើសិនជាយើងអត់បានអាផ្សេងអត់បាន20បន្ទុកទេមានន័យថាយើងឆ្លើយដែរតែវាអត់ចំអញ្ចឹងបើអត់ចំឧទាហរណ៍ថាយើងបាត់1បន្ទុក2បន្ទុកនៅក្នុងអាមួយណាមួយអញ្ចឹងណាយល់ទេជួនកាលទៅយើងឆ្លើយអត់ចំហ្មងគឺអត់បានហ្មងបានតែឆ្លើយដែរតែឆ្លើយអត់ចំក៏អត់បានដែរ
បាទ
ហ្នឹងហើយឥឡូវបើសិនជាណាគេមានអីនេះមកចាំឆាតមកខ្ញុំតាម Telegram ហើយខ្ញុំចាំទៅមើលតោះណាដើម្បីកុំឲ្យយើងខាត់ពេលនៅនេះបានន័យថាបើសិនជាមានកន្លែងណាដែលឧទាហរណ៍ថាវារៀងសង្ស័យអីយើងឆាតមកខ្ញុំមកហើយខ្ញុំចាំខ្ញុំទៅ review មើលអូខេតែភាគច្រើនដូចខ្ញុំនិយាយចឹងបានន័យថាយើងអត់បានបន្ទុកពេញហ្នឹងដោយសារយើងឆ្លើយតែវាអត់ចំបើអត់ចំវាឈប់បន្ទុកខ្លះហើយតោះមានសំណួរផ្សេងអត់ Any question Any other question So in summary one server here you need to say that you have distributed you have a lot of database okay if you only say you have one server for example like your system has one server and one database that is totally 100% centralized system so when it is centralized system it is not distributed system 100% okay អញ្ចឹងបើយើងគ្រាន់តែនិយាយថា system មួយគឺមាន server តែមួយហើយនឹង database តែមួយអញ្ចឹងអាហ្នឹង 100%គឺ centralized system បាត់ហើយវាមិនមែនជា distributed system ស្រាប់ហើយតោះណាកុំតែយើងចង់និយាយថារូបភាពវាមើលពីក្រៅទៅដូចជា distributed system ចឹងតែតាមពិតទៅមែនតែទៅវាមិនតាន់ជា distributed system ទេបើសិនជាយើងចេះអា distributed system ហ្នឹងឲ្យច្បាស់តោះណា so what the last question what I want to mention is that if you have only one server and one database 100% it is a centralized system so it is not distributed system okay but the question of the number the question of the question the meaning of the question number 7 is that some of the people say that their system is a distributed system like a lot of company declare that my software my system is distributed system okay but in order to become a truly distributed system you need to your system not like not include in this 7 point. If your system is one of the 7 point here, it's not distributed. The first point is what? You have a lot of database, distributed database, but you have only one server. Okay, so here you have a lot of database, but you have only one server. The other one is you have here you have a lot of server, but you have only one database. So that is also not distributed. The other one, you have a lot of server, a lot of database, but the whole infrastructure located in a single location. Okay, and then another one is your system is decentralized. So decentralized is not distributed. Okay, decentralized means you have several server, but your server attached with several follower. So if one server go down, the whole region go down. Only the other region not go down, but that region go down. So that is a decentralized system. The other one is your computer has a lot of server, but those computer uh, their protocol, the protocol of connection, the whole computer is leadership and follower, like master slave protocol or leader follower protocol. And then there's no election, there's no leader election. So when the leader go down, the system didn't choose the new leader. They didn't use a consensus algorithm. So that is also not a decentralized or not distributed system. Okay, even though you have a lot of database, even though you have a lot of computer, but the architecture, the topology is leader follower, and no consensus algorithm to choose the new leader. So in that case, it is also not distributed. Okay, and number 6, even if your system look really distributed, but you are using certain kind of service, so the client need to access to the service before accessing to the server. So if you have only single service, that is also a problem, because that service can go down and then client cannot connect to the server. Even the server is still running, but your service that uh, deliver the request from client to the server go down, so your system also go down. Okay. And then the other one is related to blockchain technology. So some blockchain is distributed, some blockchain is decentralized, some blockchain is also centralized. So it depends on what kind of blockchain that you are using. Okay, so that is all the system that related to distributed system, but sometimes it's not truly distributed. So the system that truly distributed is a peer-to-peer system, and then there's no single point of failure. When you see the whole system, there's nothing that is single. If you see something single, that is a single point of failure. Okay, I gave you another architecture. For example, like you have a lot of server here. Okay, your server is distributed, and then you have also a distributed database. Okay, you have also distributed database, and then your database is you have a lot of database. Okay, and then there's a connection here, and then sometimes your system is using some kind of information from another server. Okay, it get the information from one server in order to process something. Okay, in this kind of case, is also a use case problem. So when you see this part is distributed, but when you see the part that using the information from another server, and you only have one server, that is also centralized. Okay, because you get information from one single place. But if you got information from several places, it's okay. Okay, so remember that anything that related to single or one, that is the problem of the single point of failure, and then the centralized part is in that part. Okay, so if you only have one, you get information from only one place, so that is also a single place. So anything that is single or one is a single point of failure. Just remember that. Okay, so that is the last thing that I want to mention. អញ្ចឹងបានន័យថា system អីក៏ដោយឲ្យតែយើងមើលឃើញថាកន្លែងណាមួយដែលវាមានតែមួយបើទោះបីជា system នោះវាមើលទៅវាសឹងនឹង distributed ហើយក៏ប៉ុន្តែនៅពេលដែលមានចំណុចណាមួយដែលវាមានតែមួយតែអីក៏ដោយឲ្យតែមានមួយគឺ centralized ហើយ single point of failure ហើយចាំតែប៉ុណ្្នឹងបានហើយមិនថាមួយ server មួយ service ឬមួយក៏មួយ database ឬមួយក៏មួយអីទេតោះណា Okay, so I think that is the end of our question now. So do you have any question? Any other question? អត់ដឹងមកមើលមើលមានតែគេនៅនេះអត់មានទេខ្ញុំអត់ដឹងដែរហ្នឹងហើយមើលយើងហៅមើលទេ Okay, so any question? Miss Marie, any other question?
Chui vô là decentralized đong tiệt chờ.
Okay, decentralized. Okay, so your friend asked me to explain the say what? Okay, let look at this one. So here is a different kind of architecture, and the dot here refer to one computer or one server. Okay, so the first one we call centralized system, the second one we call decentralized system, and the last one we call distributed system. Okay, so centralized system, which means you have a lot of computer. It's true you have a lot of computer, but you only have one server. Okay, so everything access to this kind of server, and then when the server go down, it go down. That is called centralized system. Okay, so for example, like here, it just like this. You have one server, and then you have a lot of client here. So the other computer is just a client. Okay, so when the client access to the server here, and then when the server go down, it go down. Okay, so that is the first type of centralized system. These are the client. Okay, these are the client, but the other system is the same thing. Even if your system is all the system are server, for example, like you have a lot of computer. Okay, you have a lot of computer, and then here is the client is here. Okay, so you have a lot of client. But the way that your computer is doing is leader follower. Okay, so you have a lot of server. It's true you have a lot of server, but your server is leader follower, and you only have one leader. Okay. So if your leader is going down without consensus algorithm, the whole system is going down, because your client cannot access to this leader, because these are only the follower. So it doesn't make decision. It doesn't write information to the database. Only the server write information to the database. Only the leader. Okay, so remember, when you have a leader follower, only the leader can access to the database and read and write. Okay, the follower may be read, but only leader write. Okay, but if your leader go down, it's go down. So these are the centralized system. ចឹងច្បាស់ហ្នឹងអា centralized មួយគឺយើងមាន server តែមួយទេតោះនេះឲ្យ client ទាំងអស់ access មក server មួយហ្នឹងតោះពេលអា centralized មួយទៀតគឺយើងមាន server ច្រើនមែនក៏ប៉ុន្តែមានតែ server មួយដែលជា leader អាផ្សេងទៀត follower ទាំងអស់ក្នុងករណីហ្នឹងក៏ជា centralized ដែរច្បាស់នៅច្បាស់ centralized នៅ Okay. Yes. So how about distributed, decentralized? So this decentralized is this one. Okay. So decentralized, which means you have a lot of server. Okay, you have a lot of server, and then you also have a lot of follower. Okay, you have a lot of follower. Okay. So these are your server, and then your client is here. Okay. So here are your client. So when your computer is connected as a decentralized system or protocol, so which means all the follower is connecting to the leader. So the red one is the leader, the orange one is the follower. Okay, and then all the leader connecting to one another. Okay, something like this. Okay, maybe like this. And after that, the client can access to any leader. Okay, so this client can access to this one. 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 Something like that. Okay. And then the problem is those server is decentralized, which means it doesn't communicate in a distributed way. So it is like the server is only a replicate of another server, something like that. And then one server go down. For example, like this server go down. Okay. this server go down. Sometimes, for example, like sometimes this server is served in for Cambodia, and then this server is served for United States, something like that. This server is for serving another place, something like that. Okay. So when you when you don't have a load balancing that redirect the client to another server, so when this server go down, when this server go down, which means all the client that access to this region cannot access to the service. Okay, and there is no redirect request that redirect this request to another server. So if there's a redirect like this, it is okay. But sometimes there's no service that redirect those requests to the other server. So when this when one of the server go down, the client that access to this server cannot access to the service, but the other client is still accessible. Okay. ចា decentralized system មានន័យថាម៉េចមានន័យថាយើងមាន server ច្រើនតែ server ហ្នឹងវាតំណែងគ្នាវានិយាយគ្នាហើយវា connection នេះដើម្បីវា update data ទៅក៏ប៉ុន្តែភាគច្រើនវាចែក region គ្នាមានន័យថា client នៅកន្លែងនេះគឺ access បានតែ server មួយនេះទេអូខេតទៅពេល client ទាំងអស់នេះ access បានតែ server មួយនេះទេអញ្ចឹងពេលដែល server នេះមានបញ្ហាវាអត់មានវិធីណាឬមួយក៏ software ណាដែល redirect request ហ្នឹងទៅឲ្យ server ថ្មីទេអញ្ចឹងមានន័យថាម៉េចបានន័យថាឲ្យតែ client ណា access មកកាន់ server នៅកន្លែងហ្នឹងគឺ service ហ្នឹងគឺ go down ហើយអញ្ចឹងក្នុងករណីហ្នឹង service ពីរនេះអត់ down ទេ service ទាំងអស់នេះអត់ down ទេ down តែមួយនេះទេតែអាហ្នឹងឯង system បែបហ្នឹងយើងឲ្យឈ្មោះថា decentralized system ច្បាស់នៅ So decentralized system, which means that we have a lot of servers. So these are the server, and they communicate with each other. But the problem is there is no redirect request from one server to another server. So when one server go down, whichever client access to those server or whichever follower that connect to those server, those region are going down. Okay, unless you have some kind of service. And the distributed system is just like this. There's no server. Okay, every single computer are the same. So one could become a leader if you use a rough consensus, and then when one go down, the other one can go up. Okay, but the truly distributed system, there's no leader at all. For example, like Bitcoin no leader, there's no leader. Okay, Bitcoin is truly distributed. Rough is still has a leader follower, but the good point is when the leader die, they elect a new leader. Okay, but for the Bitcoin, there's no leader at all. Every computer are the same thing. Okay, so when in the future when we learn about the Bitcoin, for example, like here, for example, like if we have 3 computers, so in rough consensus protocol, at one time this one become a leader, okay, and the other one are the follower. And sometimes this one become a leader and the other one are the follower. Sometimes this one become a leader, okay. But in Bitcoin, there is no leader. Everyone are the same, okay. Every computer are the same, and then they compute something which is called proof of work. So for example, like I put an example, for example, like x plus 2 equal to 7. So what is the result of x? Okay, so something like that. And then this computer need to calculate this one. This computer need to calculate. This one also need to calculate. This one is also need to calculate. Okay, so you see that all the computer need to calculate the same thing, and no one is the leader. Okay, so those who find the answer first, for example, like now, x is equal to 5. Okay, and then this computer found it. Okay, so x is equal to 5, and then this computer found it. So now this computer become the leader, and then within this we call block, because blockchain is a block. Okay, so this block, this computer is a leader, and then when there's another block, there's a new calculation. For example, like x minus 2 is equal to 5. So what are the answer? Okay, so x minus 2 is equal to 5, so x is equal to 7. Okay, so the answer is x equal to 7. And now this computer found it. Okay, another computer found it. This computer found that x is equal to 7. So this computer become the leader of this block. That's why Bitcoin, you see that all the computer, there's no leader and no follower. Okay, so those who compute the correct answer will become the leader. It's different from the rough consensus and rough consensus, which has several computer, and then at a time one computer become the leader. Okay, it's the same thing. Only this one is a leader election, but this one is computing the formula, computing some kind of formula, and then the idea is the same thing. At one time, one computer will become a leader. So like this become a leader, this become a leader, something like that. But in rough, the leader will live forever until it is go down. Okay, but in Bitcoin, it change all the time. It depends on which one compute the answer correctly. Okay, So it only the idea is the different, but same thing. It need one leader at a time. តោះនេះច្បាស់នៅអ្នកសួរមិញច្បាស់ decentralized ហើយនឹង distributed នៅ
Yes sir.
អូខេហើយ Bitcoin ស្អីអានឹងចាំយើងរៀនមេរៀនមុខទៀត So rough consensus has a choose leader at a time, but Bitcoin has no leader at all. But those who can compute something correctly will become a leader. So that is the difference between a Bitcoin and the system that using a rough consensus algorithm. For example, like Hyperledger, because Hyperledger is using rough. Okay. Any other question? តោះថ្ងៃហ្នឹងបើចូលមានថ្មីព្រោះវាគិតម៉ោងដែរចូលមានថ្មីក៏អត់នេះដែរបើមានសំណួរឆ្ងល់សួរឲ្យហើយ Any other question related to our lesson from chapter 1 to chapter 5?មានសំណួរទៀតអត់ No question? Okay, I give you one last example. Okay, so for example, like we have a lot of client here. So here are the client. We have a lot of server. We connect to each other, and we have a database. Okay, and then when we want to update the system, these are the developer. Okay, so the developer is responsible for writing some code here. Okay, writing some code to update the system. Okay, so for example, like now is a version 1, and then sometime later the developer will write something here and something here and something here also. Okay, the developer will update the code here. Okay, do we consider this so the developer is only one team? Okay, so only one single team, one team. So the developer is responsible for write something to update the system. Do we consider this system is a distributed system or not? ចឹងបានន័យថាយើងមានម៉ាស៊ីន server ច្រើនត្រូវហើយម៉ាស៊ីន server ហ្នឹងវា connect គ្នា distributed វាអត់មានប្រើស្អី centralized អត់មាន leader មេទេគឺ distributed វាប្រើ RAS ប្រើអីចឹងទៅឬមួយក៏ Bitcoin ចឹងទៅហើយវាមាន database ច្រើនចឹងទៅអូខេក៏តែអ្នកដែលតែសេ software ដាក់ចូលទៅក្នុងអា blockchain មួយហ្នឹងគឺជាក្រុមហ៊ុនមួយអូខេចឹងសួរថាតើ system មួយហ្នឹងគឺជា distributed system អត់ Can we consider this system is a distributed system? We have a lot of server, no leader, no follower. All the system are using a RAF or maybe truly distributed. And then we have a distributed database. And then we have a group of developer. It could be from one company who are updating the software of the system. Do we consider this system is a distributed system? Tao,សម្បត្តិឆ្លើយបានអត់អា system ប្រភេទហ្នឹងយើងចាត់ទុកជា distributed system អត់សម្បត្តិ
ឃើញខ្ញុំចង់សួរមួយកន្លែងអ្នកដែលនៅកណ្ដាលហ្នឹងអាហ្នឹងមនុស្សមិន
អាកណ្ដាលនេះ server នេះមនុស្សតែមួយក្រុមនេះឯងអានេះ server ច្រើន computer ហើយអានេះ software នេះអាមួយនេះ software បាទន័យថាមនុស្សហ្នឹងទៅសេ software ចូលទៅក្នុង system ទាំងអស់ហ្នឹងចឹងសួរថា system ហ្នឹង distributed អត់ច្បាស់ទេតោះ author can you answer We have a lot of server, we have a lot of database, distributed server, but one company responsible for writing an application to those kind of system. Do we consider the system as a distributed system?
Yes, but it is centralized.
Yes, but centralized. Yeah, the answer is correct. Yes, the system is distributed. Okay, if we only talk about the system is really distributed. But if we talk about people, okay, because sometimes in order to involve in something, there is also people involved. Okay, so here if we only talk about the system, 100% the system is distributed. For example, like Bitcoin. But if we talk about the people, there is only one group of people who are controlling this system. So which means that the people can modify anything. If you are a developer, you can modify the code depend on what you want. Okay. So firstly, for example, like I write my system is very distributed, and then version 2, I write my system to become centralized. Okay. The system is distributed, but the way the software work is not distributed. I mean like that. Okay. So in that case, we have a centralized, maybe you can call it centralized developer, or in other case we call it centralized governance. Okay, governance. So when we talk about governance, we talk about decision making, and then we talk about people. Okay, decision making. So for example, like in the blockchain technology, some blockchain you see that the idea of blockchain is very good, the architecture or technology, whatever, but it is controlled by only a group of people, and that group of people come from one company. In that case, your system is good, it's truly distributed, but you have a centralized governance or centralized decision making, which means that whenever this group of people want to do something, it will change. Okay, for example, like I create a blockchain community. I create a blockchain community. For example, like here, I create a blockchain community. The system is distributed, and then here is me. And then now there's a lot of users who are coming to the system. So now it become a very big distributed community. But because of the software is written by me and by my group, so sometime later I ask my group to change the meaning of the software. So you can see that the architecture, the system, the technology, the hardware is distributed, but the way that we use the system is centralized depending on who is writing the software. Okay, so in that case, even those the hardware, the hardware, the architecture, the technology is distributed, but you have a centralized way of creating software and business logic, so that your all the community here need to follow me and my group, because every software is written by me. Okay, unless we have a lot of developer group from different team, for example, like here, and then if you want to modify something, some code, you need an agreement from all the team. Or sometimes people can vote. Okay, people vote for which software need to go to the next version, and that version need to upload to the system. In that case, your we call ecosystem of the your software is more distributed. Otherwise, it's only the distributed in term of technology and hardware, but the business logic and the software is centralized, because you have a centralized governance, centralized decision making. Okay, understand? That's why some of the software we call we have some proposal. Okay, for example, like some of the community said, okay, the software need this kind of feature, I want to propose it. Okay, it become the proposal number 1. The other one propose it, it become proposal number 2. And then like a lot of people vote for this one, but not yet for this one. So now this one will upgrade to the next version, something like that. Okay, in that case, the development of the life cycle of your software is more distributed. Otherwise, it's still centralized. Okay, so that is the another aspect of a distributed system. Chẳng hạn distributed system ខ្លះយើងមើលទៅគឺបើយើងនិយាយពី hardware យើងនិយាយពី technology គឺវា distributed ហើយ low ហើយតោះណាតែបើយើងនិយាយពីការសរសេរ software upload ចូលហើយ update software version អីហ្នឹងបើសិនជា software មួយដែលត្រូវបានសរសេរហ្នឹងมันមានការចូលរួមពីមនុស្សច្រើនអ្នកมันមានការស្នើសុំពី community ទេដើម្បីឲ្យបោះឆ្នោតថាតើគួរតែមាន feature នេះ feature នេះទេអញ្ចឹងsoftware ទាំងមូលហ្នឹងគឺគ្រប់គ្រងដោយមនុស្សមួយក្រុមឬមួយក៏ក្រុមហ៊ុនតែមួយអញ្ចឹងយូរទៅបើទោះបីជា system ហ្នឹងវាជា distributed system ក៏ដោយក៏ប៉ុន្តែ ការប្រើប្រាស់ system ឬមួយក៏របៀបប្រើប្រាស់ system ហ្នឹងគឺបែប centralize ដោយសារតែវាមាន centralize governance បាទអ្នកគ្រប់គ្រង centralize តោះណាចឹងពេលខ្លះយើងរៀនអស់ទៅមើលទៅ distributed អស់ហើយកុំតែភ្លេចមើលមនុស្ស centralize តោះហ្នឹងដោយសារតែមានមនុស្សគឺតែមួយក្រុមគ្រប់គ្រងមួយហ្នឹងបើទោះបីជាមានមនុស្សរាប់លានអ្នកប្រើប្រាស់ system ហ្នឹងក៏ដោយតែមានតែមនុស្សមួយក្រុមគត់ដែលគ្រប់គ្រង system មួយហ្នឹងចឹងអាហ្នឹងវានៅតែ centralize ដដែលគឺ centralize លើមនុស្សហើយមនុស្សហ្នឹងមានសិទ្ធិកែប្រែ software update software ហ្នឹងទៅតាមចិត្តគេចង់បានតោះណាហើយអាពេលហ្នឹងគឺ system ហ្នឹងវា distributed តែ technology តែ hardware តែសម្រាប់ការប្រើប្រាស់ព្រោះធម្មតាយើងមិនមែនទៅប្រើ hardware យើងមិនមែនទៅប្រើ technology ណាអ្វីដែលយើងប្រើប្រាស់ប្រចាំថ្ងៃគឺ software ហើយនឹង business logic តើណាហើយអាអ្នកដែលទៅសេហ្នឹងគឺ centralize ចឹងនាំឲ្យយើងប្រើប្រាស់ system ហ្នឹងតែមូលទៅយូរទៅ centralize ឯងតើណាគ្រាន់តែ system យើងអត់ down តែ idea របស់ system ហ្នឹងគឺ centralize understand okay so if you want your system to be 100% distributed your hardware need to be distributed, your storage need to be distributed, your service need to be distributed, and then the way you're making decision involved in people also need to be distributed. You need to have a lot of developer team. You need to have an election, not only within the software, but also election within the people. Like who are the leader now, who can make decision, who can do the development, what are the process of uploading the new version of the code into the system, something like that, so that your ecosystem is truly distributed 100%. Okay, otherwise there are still some centralized part inside your system. Okay, I think that's time now, and see you next week, and we will learn about the cryptography. Okay, and then I will discuss with our teacher if we will do our TP face to face or not. Okay, see you next week. Bye bye.
Bye, teacher.
Bye.